we need to divide because I can't graph it as it is. So we need to divide this, meaning I'm going to take my x minus 1 and divide it into our 2x minus 6. So what's going to go on the top when we divide this? Up here.
2.
A 2. 2 up here. Then we take that 2 times our whole factor guy and put it underneath. So 2 times our x gives us 2x. 2 times minus 1 gives us minus 2. And we need to subtract. Make sure we are subtracting everybody. Because what do we get as our remainder?
-4.
Our 2x minus 2x cancels out. We get negative 6 minus negative 2. It's the same thing as negative 6 plus 2. So we get a negative 4. Which means we can write this in our transformation form. I'm going to make a little pit stop in my, what I call the mixed number form. So our number on top is our whole number. And then we have our remainder of negative 4 over our x minus 1. So we could write this in our transformation form just by flipping those two pieces. So we have our minus 4 over x minus 1, and then plus 2. So this gives our transformation form here. I'm just going to close that. Questions on that part? 'Cause that's what we did yesterday. All right, then to do our graphing, we did this yesterday as well, but we also have done this before. We need our a, h, and k, and we need our parent function. What's our a?
-4.
Our a is going to be negative 4. What's our h? So think about our a over x minus h. It's going to be a 1. Yep, you're exactly right. It's going to be a 1. There we go. And our k is 2. Excellent, excellent. Oh, wrong color. There we go. Our k is going to be 2. So that gives us our asymptotes as well. So our x equals h every single time. X equals h. So our vertical asymptote is going to happen at our x equals 1. So we're going to have our vertical asymptote. If I draw it on a line properly. Like that. Our horizontal asymptote, that's going to happen every time at our y equals k. Y equals 2. So that's going to be this guy here. That's the same color as the lines that are already there. Luckily it's thick, so you can still see it. Set. I broke your brain.
No.
Okay.
Just brain loading this. So.
Understood. Just checking, because that was very much an error face. That was a signal not found static.
We were talking about theories, like those theories that are like we're secretly in a simulation or something like that yesterday during astronomy club.
Oh, yeah.
Because we were talking about dark matter and dark energy stuff.
that can lead you down several different tangential rabbit holes. All right.
Especially when you're around a bunch of nerds.
Yep.
And I mean that lovingly.
Always. So our parent function is always going to be our 1 over x. So this parent table isn't really going to change. We just have to know how to do it. So we pick our 5 values that are good to the middle. They show us the middle really good. We've got our negative 1/2. Our negative 1, 0 is undefined. Then we have our 1 and our 1/2. Again, not plotting those, we just use them. Because we use them to make our transformation form. When we do our x plus h and our ya plus k. Because graphing makes us yuck. So we're going to have our x plus h, x plus 1, and our y times a, so y times -4, and then plus k, and then plus 2. So we're going to do these transformations, a very, very old song. And it's, I believe, do the locomotion. So -2 plus 1 is -1.
What?
It's an old song from like before my time. It was an old song when I was your age. Don't worry about it. It's all good. It's just one of those I had to get it out of my head in order to make it not itch anymore. So we're adding 1. Our -2 plus 1 gives us -1. Our -1 plus 1 gives us 0. 0 plus 1 gives us 1. 1 plus 1 gives us 2. And 2 plus 1 gives us 3. Hard part is going to be our y's because they're a lot more fractiony. We have our -1/2 times -4. That's going to give us a positive 2. Positive 2 plus 2, we get a positive 4. -1 times 4 is going to, or -1 times -4, excuse me, is going to be a positive 4. Plus 2 gives us a 6. The word undefined I cannot multiply, so it continues to be the word undefined. 1 times -4 is -4. Plus 2 is a -2. And 1/2 times -4 is -2. Plus 2 gives us 0. So let's plot up those points. We've got our -1, 4, which is going to be up here. And we've got 0, 6, which is right on the edge of the graph. That's okay. And we've got our 1 that's undefined, which is right where our asymptote is, which is right where it should be. Our 2, -2 is way down here. And 3, 0. So we know it's going to connect or approach our asymptotes. So these are going to look kind of like this. Boop. Well, kind of like that. Questions on this one?
I don't know why, but I feel like today is going to be an intrusive thoughts day.
It happens. It's a Friday. And in fact, it is your second to last Friday.
And also 2 weeks until spring.
Uh-huh. All right. So we are going to be in on respect today. We're going to go look at page 17. And we're going to look at what happens when we have those crossy-outy bits. All right. So what we're going to have when we have one of these crossy-outy bits, so like when we factor stuff and it crosses out, we're going to get something called a discontinuity, which is a fancy name for somebody grabbed a pen, came up to my graph, stabbed a hole. I is a hole that has been stabbed into my graph. Our crossy outy bits stab a hole. And in fact, that's the other way we'll refer to a discontinuity, a removable discontinuity here, is a hole. Or you can call it whatever you choose to. We will most often refer to them as discontinuities, removable discontinuities, or a hole.
Why removable?
Because technically, the asymptote is a different kind of a different kind of discontinuity because it's not continuous. So removable is just, we pulled it out. There's other kinds of discontinuities. Let's just go with that. We will talk more in detail about that next year.
And DC
Uh-huh.
Oh, got it.
Oh, you'll see a lot of very similar things in DC Pre-Cal. All right. So let's look over here. So if we have a piece like this, and we have our little chunk that cancels out here, we get our leftover bit. Our discontinuity is going to happen wherever this piece that we crossed out is equal to 0. So to figure out our discontinuity, we're going to say, when does x minus 2, that piece that was crossed out here, equal 0? Well, we can solve that. What would x be for that to equal 0? 2. We add 2 to both sides. So the problem happens when x is 2, and that's exactly what it looks like over here. But since that's kind of like, a point, we kind of need to find the y as well. So what we do is we're going to grab anything that's left over after we have our removable discontinuity, our little guy here, and we get our y equals 1 over x plus 2.
Fill in the 2.
I know what x is going to be. Let's get our point because we know our y is 1 over
Undefined.
2 plus 2.
Oh, 1/4.
1/4. Because it should not be undefined. If it was up here and I substituted in my positive 2, that's when we get our undefined. Because this guy would be 0. This guy's not 0. So our y for our discontinuity is 1/4. So as a point, we have our 2, 1/4. And that is the exact address it would take to get to this point. This is 2, 1/4.
Can I get a band-aid?
Of course.
My finger.
Knee-high silver shelf.
I know that.
Totally fine. That's what they're out there for. So what we're going to do today is we're going to work with identifying some discontinuities and writing things in our transformation form. And then Monday is when we're really going to graph these things. So the very first one on the page we have, it is actually page 17, not page 16. Let's call up my page numbers are all off by 1. What?
There's one that reminds me of my food.
Ah,
I just started
that happens. I'm sorry. All right, let's take a look at this guy up here. We've got some pieces. None of them look like transformation form or something we can do anything with. What can I do on this thing if we were asked to try and simplify it? For 2x plus 10 over x squared plus 6x plus 5.
First, we factor it.
We need to factor. So, is there anything we can factor out of this numerator? The 2x plus 10?
They have a common denominator of 2.
Yeah, they have a greatest common factor of 2. So if I take a 2 out, we're left with x plus 5. Then let's look at our denominator, see if we can factor that.
See? Doge.
Oh, yeah,
I miss my dog.
it happens. So the bottom one is significantly more familiar factorableness. We're going to need to use our x. What goes to the top up here? A times c. So that's going to be a 5. And on the bottom, 6. So we need a pair of numbers that multiplies to make 5 and adds to make 6. 1 and 5. Multiply to make 5, add to make 6. So we can write this into our factored form of x plus 1 and x plus 5. So what do we notice here? Let's put this in factored form. What do we notice here? The x plus 5 piece cancels out. This guy and that guy are exactly the same. So my remaining function, we've got 2 over x plus 1. That's what's left over. This guy is our piece that causes our discontinuity. That's what gives us the little stabby hole. So to get our x value for where that's happening, we're going to look at when does x plus 5, that guy we crossed out, when does that equal 0? That's where we're going to get our information. So when does x plus 5 equal 0? When x equals what?
5.
Careful.
-5.
So x will need to equal -5. So to get the y value of the point, we're going to take our -5 and substitute it into our y equation. We need to go with the leftover one, not back up to the original. Use their leftovers. In the original, you will get a 0, which will give you an error. So our y is going to come from 2 over our x, which is -5, plus 1. What is -5 plus 1?
-4.
-4. So we have 2 over -4. What's 2 over -4? Flip it. You did 4 divided by -2.
Oh. 1/2.
We're going to have our -1/2. So our discontinuity is going to happen at the point -5, -1/2. Is this leftover bit in transformation form or in quotient form? It's in transformation form. Because we don't have any x's left in our numerator, we're in transformation form, so we do not even have to do any dividing stuff. Huzzah. So our transformation form is our y equals 2 over x plus 1, which means I know my asymptotes, because what's my h? -1. So if I know my h, that means I know my vertical asymptote is our x equals -1. What's my horizontal asymptote? What's my k? 0. So y equals 0. So now I have my 2 asymptotes, I have my transformation form, and we've got this point. We could plot this up. We're going to plot them up on Monday. I just wanted us to practice doing this bit first. Finding all of our pieces. So questions on our first one like this. Okay, let's practice it again. Let's look at number 2, next page, page 18. We have x squared minus 4x over x squared minus 16. What should we do first? Factor. Which one are we going to look at? Our numerator or our denominator first? Numerator. What are we going to do with the numerator? How can I factor x squared minus 4x?
Well, we're missing 0.
We're missing a term. Which term are we missing?
The normal number.
The normal number at the end. We don't have... Oh, I don't like that. We don't have a c value on this one. So what do those two pieces have in common? Can I do this without a c?
No.
No. How can I factor that then?
Difference in squares. Greatest common factor.
What is their greatest common factor?
X.
X. I can factor an x out of both of those pieces. We get an x minus 4 left over. So this numerator just has a greatest common factor. What about our denominator? What's going on there? Factor, more specific.
Since there's no singular
Mm-hmm.
x,
Mm-hmm.
it would be 0.
We don't have a b term here. So that one, we can use our x. Totally fine. We know our a, we know our c. We have negative 16, and we have no b's. So what pair of numbers will multiply to make negative 16 and add to make 0?
4 and negative 4.
4 and negative 4.
Difference in squares.
Also known as the difference of squares pattern. Because this is x plus 4 and x minus 4. So you can do that using the x frame, just like we've done for all our other factoring. You can do that by noticing that, hey, that's x squared and 4 squared, and go with that way to get our pattern. But we do need to be able to factor these. Again, I don't care how we factor, just that we factor, though I do need you to show me what you did. So what do we notice here? Now that we have this thing in factored form, what do we notice?
There's x minus 4 in both.
There's an x minus 4, both numerator and denominator, which means I can cancel those out. I can cancel top to bottom if they're exactly the same. So what we're going to have left over is x over x plus 4. Let's find our discontinuity first before we deal with anything else. So I know x minus 4 causes a discontinuity when it equals 0. Every other time, it cancels out. So our x value on our discontinuity is going to be what? When does x minus 4 equal 0?
Oh,
When x equals 4.
wait.
What's that?
What did the brain can't.
Process for a moment.
So we do the one that we cross out.
The one that crosses out is the one that causes the discontinuity.
Okay.
Yes,
That makes more
it's always the crossy outy guy. And then even when this is looking a little bit gross, because this is not transformation form, this is gross things, we can still get the y value of our discontinuity using that. I can get my y equal to, and look at 4 over 4 plus 4. Lots of 4s. But substituting this pink 4 from our x minus 4 into both x's.
1/2.
Yeah, because we get y equals 4 over 8, which is the same thing as 1/2. So our discontinuity is going to happen at the point 4, 1/2.
Will our y's always be fractions?
No, but frequently.
Okay.
Not always, but as the structure of a rational function is mostly fraction, it's going to be a lot of times. But there are also a lot of times when it'll come out nicely, if we can manage it.
For once. Probably going to be rare.
I was gonna say, it's gonna happen occasionally, but not often. All right, so that's all of the new bit. Let's practice this part because we want to get this in a transformation form because Monday we're going to be graphing these things.
Ew.
So this guy, our leftover bit, is in quotient form. We've dealt with quotient form. We did that in the bell work. We did that yesterday. That's what that does. So to switch this into our transformation form is when we're going to need to divide. We're going to divide our x by x plus 4. What's going to go on the top for this division? X times what is going to give us x? Oop.
Wait, could you repeat that?
I was asking what would go here? X times what gives us x? 1.
Brain had to process that.
Understood. It's early, but unfortunately, like, y'all's final is going to be early. So, like.
True.
So we take our 1 times our factor and we put it under. We can have our x minus x plus 4. We have to subtract the whole thing. X minus x gives us 0 x's. That's what we wanted. It's supposed to cancel out. And then what this is essentially saying up here is 0 minus 4. So negative 4. So again, I tend to write this in my kind of mixed number format before I put it in transformation form. That lets me get my number on the top and my remainder in the right places because my brain wants to flip them so badly. So I have to write them like this in that mixed number because that's a more familiar structure to me than going straight into the transformation form. My brain wants to shuffle them so badly. So our transformation form, we have our minus 4 over x plus 4 and then plus 1.
My brain period.
That's okay. It's early and we have, what is it, we're at 14 days left?
Well, my brain is like this, like, past couple things. I think I may need to get some.
It happens. So let's grab our asymptotes on this one. What is our vertical asymptote going to be?
One moment. Vertical is x, so that would be negative 4.
X equals negative 4. And what's our horizontal asymptote going to be?
Y equals,
Y equals 1.
I don't know why I said that.
It's okay. Point came across. We got it. It's all good.
YouTuber at the charity match in England who pulled out a reverse Uno card when he got a yellow flag.
I think I have seen that.
Yellow card, Max Fosh. And then the following year he had a specially designed shredder.
Nice. Questions on this one? Let's do one more. This will be our last one. We'll do 3. Because it's not a super long one. So let's take a look at this. Can I factor a numerator at all?
Lord. I have no idea.
Not really. X squared is just kind of x squared. It kind of is. If you really feel froggy, you can write it as x times x. If it helps, great. If not, you don't have to. You can write it as x squared. What about our denominator? What can we do here? X squared minus 9x.
Greatest common factor.
Of
X.
x. So we have an x, and we're left with x minus 9. So what's our bit that cancels out? What can we simplify up here? The x. The number of people trying to learn this on Instagram right now is kind of shocking.
Would we still be able to do that if we... How would we do it if we put x squared instead of x times x?
So the way we could write that, so like if we had x squared and we noticed we still had that x there, we'd say, well, that x cancels out with that guy.
Okay.
And we're still left with x over x minus 9.
Okay. Boom.
So our bit that cancels out is the x. So our leftover equation, we have our x over x minus 9. And our problem child here is this x. So we find our x value for our discontinuity when x equals 0, our crossy outy guy. So let's see what happens for our y value. Our y equals x over x minus 9. What is 0 over 0 minus 9?
It's 0 over -9.
Also known as?
1 over.
Nope.
Wait.
I have no cookies to split among my 9 friends who are very far away. -9 friends. If I have no cookies, how many does everybody get?
Under 5.
Only if I have no friends to split my cookies with is what is undefined. I have no cookies to share with my friends.
Brain camp.
It's just that everybody gets no cookies.
0.
Is a 0. So our discontinuity is at 0, 0. It's right on our origin. So we could get this to transformation form, same way we've done before, divide by our denominator, x minus 9. I'm going to work this just because we have like 3 minutes left and I want us to get there. We're almost there. But we're going to have our x times what gives us x, and that's a 1. We multiply our 1 times our whole factor. We get our x minus 9 underneath, and we need to subtract everybody. Our x's cancel out, and we're left with 0 minus -9. So we actually got a positive 9 here. Because we have, this is the same thing as if it said plus 0 right there. 0 minus -9. So our kind of mixed numbery looking thing is going to be our 1 with our 9 over x minus 9.
Okay. We're going to process something.
So our transformation form is going to look like if we just switch their 2 spots, our 9 over x minus 9 plus 1. So from there we can grab our asymptotes, our vertical asymptote that happens at our x equals h. So that's going to be our x equals 9. And our horizontal asymptote happens at our y equals k, so our y equals 1. So come Monday, we're going to take all these pieces that we find and we're going to graph them.
Oh, yay.
But that's as far as the graphing goes. Like we're not adding more to it even then. So this is as bad as the graphing stuff gets.
Are you sure?
Yes. For this year. I'll get you through it. It's all good. All right, so the homework for this is not due until Tuesday because we haven't actually done the graphing part yet. There's not anything different about the graphs. You could probably do them, but we're going to do them together on Monday. So the homework's not due till Tuesday, but you should turn in your bell work from this week. I think we only have 1 more week of bell work. Might have 2, but I'll see. I know.
No.
I know.
I don't want to be a senior.
well, tough cookies.